Good morning, students. This one is the third lecture of your VLSI system design subject, and in this lecture we will discuss about some modularity and locality topic. So let's start our topic. This one is your syllabus, modularity and locality. These two topics are covered in this lecture. So first of all, what is modularity? In one statement you can easily understand modularity means design each block of any each block of any system independently. uh, it means that suppose you need to design a system, and the system consists various block. It means when we combined each and every block, one block output of one block is connected with the input of another block, and output of second block is connected with the input of third block. When we make a system by combining these individual blocks, then at the time we can say the whole system is a combination of various functional blocks. So this modularity strategy means that this one is the design approach. The modularity design approach, according to this modularity design approach, the function of each and every block generates independently. It means that when we design a system, and for making a system, if we implement a functional block individually, then it is much easier to design a system, because if any error occurs in the system, then if we implement if we implement the system by designing the each functional block independently, then we can easily recognize where in this channel the error occurs. Okay, so this one is all about modularity. According to your textbook, modularity means various functional block has well defined functions and interfaces so that they can be implemented and tested separately. Okay, it means that when we design a system by combining various block, then the function of each and blocks and interfaces between two blocks are implemented separately. Okay, the second point is if modules are well formed, the interaction with each other modules may be well characterized. Okay, it means that if we design each and every functional block individually, and the characteristic of each functional block is well defined, so we can easily recognize the error, and we can easily recognize the error if it occurs in the system, and easily correct the error. Okay, the third point is the notation of well formed may differ from situation to situation. According to a system, the well defined notation is changed, but a good starting point is the criteria placed on a well formed software subroutine. Okay, we can easily understand this modularity topic in program by considering any program. As Suppose we need to generate a program for any system, so it is much easier for the designer if first it implement a subroutine, and subroutine for each and every block, and after it connect one subroutine with another, and complete the whole program. Then at that time it is much easier strategy to design a system. Okay, the block can be combined easily at the end of the design to form the large system. If we implement each and every functional block individually, then we can easily combine one block with another and complete the whole system. Okay, the modularity helps the designer to clarify the document and approach to a problem. Okay, modularity enables the parallel design process. What is the mean of this parallel design process? It means that we know that any system is a combination of various functional block. Okay, so if we design a functional block, then we can design each functional block individually, separately, and after the completion of each functional block, we can connect one functional block into another. So this strategy saves the time for the designer and implement a good system. Okay, this one is all about modularity. In short, you can understand modularity means design each different block individually, so it is much easier for the designer to implement the implement the system, and it also saves the time of the designer. Okay, this one is the design approach of in VLSI system. Okay, now the next point is locality. What is the mean of locality? Okay, we can easily understood locality means that the each functional we when we design any system, then each functional blocks are very much close to each other. This is the whole definition of locality. It means that locality ensures that the connection between two modules is proper. That means if we design any modules, then the connection between two modules are proper, and they are very close to each other, so that the interconnection between them is very less. If the interconnection between two modules are less, then we can say the transit time of the signal for from one functional block to another functional block is very less, so this speed up the process of the system. Okay, in other words, we can say it avoids the long distance connection between two blocks for proper functioning. Okay, I think you can understood locality by this sentence only. Okay, the long distance connection generates delay between two modules. So locality suggests that if we design any system by combining the two subsystem, by combining the two functional block, then the distance between two functional block is very much less than, which is very much less, so that if the distance between two functional block is less, so that the delay time is also less, so it speed up the process of the system. Okay, next point is locality ensures that the internal connection of any modules are not visible to any exterior interface. Okay, the third point is locality also enables the outside world to treat each module as a block, is a black box with well-defined input and output. Okay, this one is all about locality topic. Okay, thank you so much. In the next lecture we will discuss some other topic. Okay, thank you so much.